students, welcome again to another lesson for maths at senior level. Now, today's lesson will be a continuation of the topic we started last week, that is the introduction to vectors. Today we'll be going a little bit further by looking at the basics of vector algebra. Now, I know the benefit of the students who are not science-based or science-inclined. You may have a little bit of struggle, or you may have issues if we go too deep into vector analysis. But I will touch the basics so that you have some foundation. At the same time, still appreciate what vector algebra is all about. So if you're ready, let's begin. Right, following from last week, we looked at how we can represent a vector. And I did mention that as far as vectors are concerned, the direction is the bit that matters the most. Alright? Now, look at the projector screen here. We have the vectors PQ and RS. Okay, let's start with vector PQ. You can see clearly we have 2 points, P and Q, and you have the vector PQ, which clearly suggests here that the vector is starting at point P and ending at point Q. Because remember, like I said, the direction of the arrow matters. Okay? So you have the vector PQ, which, like I said, shows that the vector starts at the point P and then terminates at the point Q, following the direction of the arrow. Okay, so this is one way to represent that vector. The other way, if you recollect from last week, is when you use a notation. So in this case, we have letter A with the underline to show that it's a vector. So the vector A is the same as the vector PQ. And now, let's go into more detail with regards to this. To go from P to Q, you have to go 1, 2, 3. 3 units along the x-axis and 1, 2, 3, 4, 5. 5 units along the y-axis. So if you want to write this, the vector A can also be written in vector form as 3, 5. Meaning 3 along the x-axis and 5 along the y-axis. Okay? Now you notice that these numbers are both positive. I'll explain that in more detail a little shortly. Next up, look at the vector RS. The vector RS, which is otherwise noted by the vector B, or the vector of the letter B, and of course, remember, like I said, vectors are denoted with an underline. Okay, you have to put an underline to actually indicate that it is indeed a vector. Alright, so the vector B, or if you prefer the vector RS, starts at R and terminates at S. So to go from R to S, let's see how you proceed along the horizontal axis and the vertical axis. So to go from R to S, you'll have to go first 1, 2, 3, 4. 4 units along the x-axis and 1, 2, 3, 4. 4 units down the y-axis. Now remember, this time we're going down. Because we're going down, it's going to be, can anyone guess? Negative. Exactly, it will be negative. So there you go. So to go from R to S, or if you prefer the vector RS, we'll have 4 units along the x-axis and then 4 units down the y-axis. So if you want to write that in column form, it's going to be 4 minus 4, meaning 4 units along the x-axis and 4 units down the y-axis. Okay, now this is positive because it's going to the right, but negative here because it's going down. Remember when you compare to this is going up, that's why it's positive. This is coming down, that's why it's negative. This is going to the right, positive, and that's also going to the right, positive as well. So take note of all this. Alright? Which therefore takes us to the common notation of vectors. So for the common notation of vectors, you will have a number above and another one below, meaning you have two rows. Two rows of number, just one column with two rows. The first row is the x-axis, and the second row is the y-axis. Okay? So the top number describes the horizontal movement in the x-axis. Now, if that value is positive, it means you're moving to the right. If that value is negative, it means you're moving to the left. And have arrows to indicate that. So if you go into the right, it's positive along the x-axis. If you go into the left, it's negative along the x-axis. So that's the first number above. How about the number below? What does that number describe? The bottom number describes the vertical movement in the y-axis. Positive, if that number is positive, it means it's going up. And if that number is negative, it means it's going down. Okay? So always take note of that. This is very important. Always take note of that. Okay? So let's get some more examples. Now I've got a rather long red arrow there. Okay? But we started with this vector B. The vector B has got the component 4 minus 4. Okay? The vector B has got the component 4 minus 4. And that's the vector B. Now, for those of you who cannot see that clearly, to get the vector B, we start from there. 1, 2, 3, 4 along the x-axis because it's positive, and then minus 4. We're going down. 1, 2, 3, 4. So that's the vector B. Alright? But I've indicated the vector B there with the blue arrow. Let's see how that compares with the long red arrow. Now you'll observe that the two arrows, the blue arrow, the shorter one, and the red one, which is longer, are pointing in the same direction. Okay, they're both pointing in the same direction. And then where they're pointing in the same direction, clearly you will notice one thing, that the two are parallel. Exactly. The two are parallel. It's just that one is shorter and the other one is longer. But let's see how does the two, how do they actually compare? How does this, the blue arrow, how does it compare with the red arrow? And I have a little animation for you to get a better picture, have a better understanding of the relationship to the two arrows. Now watch. There's vector B. How many B's are we going to have in the red arrow? Or how many blue arrows are we going to have in the red arrow? Okay. There's one. There's two. And let's see if we can fit in just one more. There's 3. So you can see clearly, and please take note. Always denote vectors with an underline. It's important. Very important. Okay. So in the red arrow, we can actually fit 3 blue arrows. In essence, 3 times B, okay? Of course, from here, there's a vector B, which is the blue arrow. If you multiply that by 3, what are you going to get? 3B will now be equal to 3 times, remember B has got 4 minus 4. Okay? And of course, you simply multiply each of these with the number on the outside. So this becomes 3 times 4, that gives you 12. And then 3 times minus 4, that gives you minus 12. And this will be the vector 3B, which is the red arrow. Okay? And what it means is, for that long red arrow to go from the beginning, the starting point of the arrow, to the end, you have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 along the x-axis, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 down. Okay? So that's why you can see clearly you have 12 along the x-axis, positive x-axis, and then minus 12 because we're going down the y-axis. So for the vector 3b, the component is 12 minus 12. Okay? So far so good. Let's move on to the next slide. Now, when you multiply a vector by a scalar, and by scalar I mean just a number, what do we have? If we multiply a vector by a scalar, it's the same as adding to that many times, which is what we saw in the previous slide. Let me just go back very quickly. So when you multiply a vector by a scalar, you're simply repeating that scalar, that vector, by the number of times you've got to the right. So here, you're repeating that vector 3 times. Okay? So there you go. 3b is the same as b plus b plus b. So in common vector form, we just have to multiply both the horizontal and vertical components by the scalar, or just by the number, just like we saw in the previous slide. So whenever you have n, which is a scalar, times the vector, you take the number n to multiply each of those. N times c gives you nc, and then n times d gives you nd. Alright? Now we have the vector a, which in component form is 3, 5, meaning you have to go 3 units on the x-axis and 5 units on the y-axis. Let's see, if you start from there, you have to go 3 units to the right, 1, 2, 3, and then 5 units up. 1, 2, 3, 4, 5. Exactly. Okay, so that's a vector A. But now, what if you've got minus A? Now, with minus A, it's still going to be the same size, but because it's minus, the direction of the arrow changes. It will be opposite because it's minus. Alright? Now, if we take the negative of a vector, it's the same as just reversing the direction of the vector. So the sign is exactly the same. It's just the sign. The sign is the same, but it's just the sign that changes. So A is 3, 5, but minus A, minus 3, minus 5. Okay? So there you go. It's exactly the same length, but just that the direction changes. Okay? And I hope you all can see that. Look at A, 1, 2, 3, 1, 2, 3, 4, 5. But minus A, you have to go minus to the opposites, 1, 2, 3, and then minus 5, down, 1, 2, 3, 4, 5. So it's the exact opposites. The exact opposite. Same size, same length, just the opposites. Okay? Now let's move on, and this is really important. Notice that we haven't mentioned anything about the origin. Okay? The vector could be anywhere, and it's still going to be the same. So all you need to do is anywhere you put the vector, doesn't matter. Just make sure you identify the starting point. That will be your origin, and then the end point. Okay, it could be anywhere. Okay, so we have these different arrows. They all have the same size, and they're all pointing in the same direction. So they are all still essentially vector A. Nothing changes. They're all still basically the same. Okay? Now moving on, again, let's bring back the vector A. And now, let's add another vector B, pointing as shown. So we have two vectors A and B. There's vector A, 3 and 5. For those of you who cannot see, A, you have 1, 2, 3 along the x-axis, and 1, 2, 3, 4, 5 along the y-axis. But how about B? Now, can anyone give me the component form of B? You guess. Let's see. B starts from there. So you have to go 1, 2, 3, 4 along the x-axis, which is positive, and then 1, 2, 3, 4. Down. So it's going to be minus 4. So for B in component form, it's going to be 4 minus 4. Exactly. Okay. So B is 4 minus 4. Okay. So now let's see how these other arrows compare with A and B. So how can you write these other arrows in terms of A and B? Okay. Let's see. Look at this. This is A. That's 2A. You can see clearly they're both pointing in the same direction. And when you look closely, the red arrow is actually twice the length of the blue arrow. And they're both pointing in the same direction. That's why, it's just the size that changes. It's still positive because they're still pointing in the same direction. And you can see that clearly from the fact that they're both parallel. They're both parallel. Alright, so if you can write one vector as a scalar multiple of the other, that shows that they're pointing in the same direction. They're both parallel. Alright, but look at this. The green arrow, it has exactly the same size as a B, but it's pointing in the opposite direction. Look at B. B is pointing down. That is pointing upwards, but they have the same size. So that clearly is minus B. Alright? Now this, looks pretty much as that, but it's half of it. Look, this is 4 minus 4. When you look at this, 1, 2, 1, 2. So you have 2 to the right, 2 down. So it's going to be half of that. You divide this by 2, you get 2 there. Minus 2 there. And that is the perfect arrow. Okay? Now move on to B. Look at B. B is pretty much the same as that. Look at this arrow, the rather light blue arrow and that. It's still pretty much the same. Pointing in the same direction and having the same size. Exactly the same. This is still exactly the same as that. So they're both the same vector. And last but not least on this, the orange arrow. The orange arrow is pointing in that direction. You can see it's exactly the same size as this, but it's pointing in the opposite direction. So while the red arrow is 2A, the orange arrow is minus 2A. Same size, or the same magnitude, but pointing in opposite directions. Okay, just take note of that. Let's move on. Okay, now again we have the vectors A and B. A is 3, 5, and B is 4, minus 4. Let's see what happens if we combine the two vectors together. So when you combine A and B, look at what you have. A and B, when you combine A and B, you get A plus B. Alright? Now use the component form. That's A in component form. That's B in component form. And so now when you add two vectors, what will be the component form of A plus B? When you do that, that's what you get. And for those of you who can't see that clearly, I'm just going to show you. There you go. So A is 3, 5. And then B, 4, minus 4. B, 4, minus 4. And so when you add two vectors together, 3 plus 4 gives you 7. And then 5, well, plus times minus gives you minus. So 5 minus 4 gives you 1. And so there you go. That's how we arrive at the component form of the vector A plus B. Alright? And if you can remember from the last class, the vector A plus B is actually the resultant of vectors A and B. Okay? So far, so good. Let's move on. Now, here's another one. Again, we have A and B. This time, we want to combine B with A. And you can see clearly that the direction of the arrows, the direction really matters. It matters a lot. So when you combine the vector B with the vector A, let's see what the resultant will be. Okay, that gives you B plus A. And there you go, look at the direction of B plus A. It's going to be in that direction. But then in component form, what will it be? You have component form of A, 3, 5, and then B, 4 minus 4. Therefore, for the resultant B plus A, what do you reckon will be the component? Can you guess? You can pause the video and do that quickly. And once you're done, you can continue playing the video. So, if you try that, you should get 7 and 1. And for those of you who didn't quite get that right, it's quite straightforward. It's simple addition, alright? What are we adding? We adding the component form of vector B, which is 4 minus 4, together with the component form of vector A, which is 3 and 5. And so when you add this together, 4 plus 3 gives you 7, and then minus 4 plus 5, that gives you 1. And that's how we got that. Okay, so far, so good. Alright, so let's move on to the next slide. Okay, now I've got a couple of information for you here. When adding two vectors in a diagram, you place the second vector at the end of the first vector. In column notation, this means we just add the horizontal and vertical components. So if we have two vectors A and B, it doesn't matter which order we add them. We get the same resultant vector. Right? So when you add in vectors, it doesn't matter which comes first. A plus B gives you A plus B, or that B plus A when you add the vectors together. And that's what we call the commutative law. In maths, that's what we call the commutative law of addition. Okay? So when you have C, D, plus E, F, the same as C plus E for the x-axis, and then D plus F for the y-axis. And so A plus B is exactly the same as B plus A. This is just the mathematical interpretation or the vector interpretation of the commutative law. Alright? Moving on quickly. Right, again we have the vectors A and B, their component forms given as shown. How you combine A with minus B. Now, there's the vector B pointing in that direction. Minus B will have the same size, but it will point in the opposite direction. So there you go, there's minus B. So exactly the same size, but this time it will point in the opposite direction. So now, we want to combine the vector minus B with A. Remember, this is going to be A plus minus B. So what do? We put the two vectors together and find the resultants. Okay, we put the two vectors together like that. So remember when you're adding vectors, you start at the beginning and then end. Now where one vector ends, that is where you put the beginning of the second vector. Alright, and then once you've done that, from the start to the finish, that will give you the resultant vector. So as this in this case, so we combine the vectors A and minus B. So you have A minus B is exactly the same as the vector A plus the vector minus B. Alright, and that's what gives us that. But in component form, remember you have A, there's your A, but this time minus B. So it's going to be minus B, which is going to be minus 4 minus 4. Okay? So, well, by the way, there's your vector A minus B. It's going to point in that direction. Okay? And in component form, that's what you will have. But let's put everything together to see clearly. There's a vector A, and then minus, there's a vector B. Okay? So you now have 3 minus 4, and 3 minus 4 gives you minus 1, and then minus times minus gives you plus. So 5 plus 4 gives you 9. So the component form of vector A minus B is minus 1 and 9. Meaning you have to go, so if you're starting from there, you have to go 1 unit to the left, 1, and then 9 units up. So there's 1 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 to get from the starting point to the end of the line. Okay, so far so good. Let's move on. Right, now I've got some examples for you to try out here. Vectors and the components. So what I want you to do, I've got a couple of vectors here. The vectors A, B, C, let's see there, D, E, F, and G. And what I want you to do is, you may want to pause the video for a while. I want you to write down each of these vectors in component form. And remember when I say component form, I want you to put it in a column where the first entry at the top will be the x coordinates, and then the second entry below or at the bottom will be the y coordinate. Taking into consideration the fact that it's going to be positive if it's moving to the right along the x-axis, and negative if it's going to the left, and then positive if it's going up along the y-axis, and negative if it's coming down along the y-axis. Okay? So, like I said, you know to pause the video for a while, maybe like a few minutes, and then give yourself a go, and we'll see what the answers are here. Alright? So once you're done, you can then continue playing the video. Alright? So let's see. I may have to change this and select the pointer. So let us see what you reckon will be the vector A in component form. Now I'm just going to give you a hint along the way for those of you who cannot see clearly. A, look at the direction of the arrow. There's the direction of the arrow. A is starting there and then ending right there. So it means when you start there, you have to go, well, you have to go along the x-axis first, either to the left or to the right, and thereafter you go along the y-axis, either up or down. So let's see, if you start from there, you have to go, oops, sorry. Go all the way back. Right, so you have to go 1 unit to the right along the x-axis, that's positive, that's 1, and then up, if you're going up along the y-axis, it's going to be positive as well. But how many units do you go up to get there? So you have 1, 2, 3. So what do you reckon will be the vector A in component form? Well, I've given you enough hints. Let's see if you write 1, 3. Well, if you got that right, well done. Yes, you have to go 1 unit along the x-axis, positive to the right, and then 1, 2, 3 up along the y-axis. So that's 1, 3. Okay, how about B? Again, be mindful of the direction of the arrow. Be mindful of the direction of the arrow. So look at B. B is pointing that way, so it means you're going to start there. We'll go this way along the x-axis and that way along the y-axis, meaning we're going to the right, which is positive along the x-axis, and then up along the y-axis, it's going to be positive as well. So but let's see, along the x-axis, you have to go 1, 2, 3, 4, 5 units along the x-axis, which is positive 5, and then just 1 unit along the y-axis, up along the y-axis, which is going to be positive as well. So your answer will be what? Can you guess? Well, let's see. 5, 1 exactly. 1, 2, 3, 4, 5. 5 and 1. So far, so good. Okay, you got that right as well. Well done. Moving on to C. C. Can anyone guess what C is? Well, let's see. C is 2 minus 1 exactly. Look at the arrow. You have to go 1, 2 on the x-axis to the right, and then going down. Going down, remember it's going to be negative. 1, 2, 3. So that's 2 minus 3. Okay, and how about D? D and 1. Okay, D, your answer should be minus 4 and 2. E, minus 4 and minus 4. F, minus 1 and 1. And For G, which is the last question remaining for this little exercise, let's see. So for G, that is the component representation. Now, if you manage to get all that right, it's a well done to you. That is brilliant. Now, if you didn't get all the questions right, don't worry. I just want you to take note of the mistakes and learn from it. I know that the bit that has to do with the negative, you have to be extra careful. Just bear in mind the fact that along the x-axis, going to your right, it's always positive. If you go to your left, negative. Along the y-axis, if you're going up, positive. If you're going down, negative. Just take note of that and you will be fine. Okay, let's quickly move on to the next. Now, let's add these vectors. Remember, when you add in two or more vectors to get one, you are actually finding the resultant of the vector. So, in this case, we have the vector xz, the vector A, and again, like I said, be mindful of the arrow, the direction of the arrow. And then you have zy is vector B, and then we have xy, so we're going to find the vector xy. Now again, of course, you will notice that you will need to write each of these vectors in component form, okay? So let's start with A. Look at the vector A. To go from x to y, you have to go this way on the x-axis, or I should say this way on the x-axis, and then this way on the y-axis. So let's see what the vector xy are to prepare. The vector A is in component form. There's the vector A. Vector A, or to prepare the vector xz, it's going to be 1, 2 on the x-axis. That's why it's positive. It's going to the right. And then you go up. 1, 2, 3, 4, 5. And because you're going up along the y-axis, it's also positive as well. So in component form, the vector xz, or if you prefer the vector A, is 2, 5. How about the vector zy? Again, you start from there. To get there, you have to go 1, 2, 3, 4, 5 to the right along the x-axis, and 1, 2, 3 up along the y-axis. So the vector B in component form will be 5 and 3. So there you go. Again, those of you who didn't quite catch that, you start from there because look at the direction of the arrow. Start from there. 1, 2, 3, 4, 5 along the x-axis, and it's possible because you go to the right. And then 1, 2, 3 up along the y-axis, and just going up, that's why it's possible to have 5. So there you go, we have the vector xz and zy. So now, what you reckon would be the vector xz? And remember, the vector xz is the resultant of the two vectors A and B. So we're simply adding A and B to get xz. So when you add that in component form, you're simply adding these two vectors. That's all you're doing. Okay, and so when you add two vectors together, what do you get? That's what you get. 7 and 8, because 5 plus 2 gives you 7, and then 5 plus 3 gives you 8. Well, I don't want to write it because I would need to select the pen, though, if I want to write. But what do you notice about the numbers in 7, 8 when compared to 2, 5, and 5, 3? Well, it's just like I've explained. It's the resultant. And when you find the resultant, you're simply combining the vectors. When you combine the vectors, you're simply adding vectors together. Okay? Oops, sorry. So let me just review what I have here. Right? So we've simply added the x values and y values to describe the combined movement. That is, A plus B is the component form 2, 5 for A, and then 5, 3 for B to get 7, 8. So xz plus zy gives you xy. And if you all are quite observant, something is missing in this diagram which is really, really important. It's with the xz. I've not indicated the direction of the arrow. The arrow should be pointing that way. So it's very important. In vector, the arrow the direction is really important. And we indicate the direction with the arrow, so very important. Okay, so you may have left that out, but don't when you're doing it. What you put it really matters. Okay, so far so good. Let's move on to the next slide. Now, scaling vectors now. When I say scaling vectors, all I simply mean is when you multiply a vector by a number to get another vector. Alright? So we can scale a vector by multiplying it by a number. That number is what we call the scalar. So if you have the vector A, which is 4, 3, and then you have 2A. So the scalar here is 2. You're multiplying 2 by the vector, and that's simply going to give you 2 times A, and then 2 times, 2 times 4, and then 2 times 3. Well, let's review what we have here so you can all see. So 2A will be 2 times 4, that's 8, and then 2 times 3, so you're going to have 6, 8. 8, 6, I should say. 2 times 4 is 8, and then 2 times 3 is 6. Now, what is the same about A and 2A, and what is different? So when you compare the two vectors, well, obviously, they're both pointing in the same direction. Meaning, if they're both pointing in the same direction, clearly as you can see, they are both parallel. So that is the same property that they both have. But the difference, as you can clearly see, is that one is shorter, one is longer. So the length of arrows is not the same. Okay, so what's the same? They're both pointing in the same direction, meaning they're both parallel. They're both pointing in the same direction, both parallel. What's different is the length of the arrows. One is shorter, the other one is longer. There you go. So the length of the vector known as the magnitude is longer. So note that the vector letters are underlined. We normally underline the vector letters, but the scalar is not underlined because it's just a number which multiplies the vector. Okay, moving on very quickly. Now, here's another exercise I want you all to do. I want you to expand and simplify the following expression, and this is just a basic vector algebra. If you know your normal algebra in math, it's pretty much the same, dealing with letters. It's exactly the same with vectors here. It's just the letters will not have an underline. It's pretty much the same. Okay, so you can pause the video and then quickly do this, and it's not really as hard as it looks. It's just another thing we do when you are carrying out any algebraic manipulation with letters. It's just that this time they're not just letters; they are vectors. Okay, so when you do that, you should get this as your answers. Number 1, there you go. 2A plus 2B. And then 2B plus B gives you 3B. Alright? Now again, be mindful, just make sure you put your underline there, sure it's a vector. Always take it to that. And we have number 2. There's number 2. That should be your answer as well. Okay? Number 3, you should get that as an answer. 3 over 2A plus 1 over 2B. And then number 4, that is expected to be your answer. And then finally number 5. That is your answer as well, okay? And please, as I said, always make sure you put the underline at the bottom of those letters to show that they're vectors. It's very important, okay? Now, again, the very last lesson for today, I want you to identify which of these are parallel and which of them are not, okay? And we have that, so just indicate whether yes or no, and well, again, like I said, please pause the video for a while and then go over the answers. And then once you're done, let's just check your answers with mine to be sure that we are doing the right thing. Okay? Touch wrong. So there's your answer. There's your answer there. There's your answer there. Let's just okay? And just before we wrap up this lesson, I want you to take this as homework. I will attach your homework along with the schedule for the lesson. I want you to download that and attend the questions after you've watched the video. I want you to send the answers to my inbox. Alright? And that brings us to the end of today's lesson. Thank you so much. I shall see you some other time. Stay safe. Bye for now.